know that traditionally developing for Quest and XR in general has been pretty difficult, right? Like you had to go through documentation just to get your project set up and running. You had to put on your headset every time you wanted to debug something. And the more complicated your experience, the more difficult it was debugging and iterating on it. I see some nods, so I think especially the people that have been developing for a while are resonating with what I'm saying here. So the good news is that today, I want to tell you how we have evolved our development tooling to set you up for success, and how we spent the last few years developing tools that result in a step change of how easy it is to build for MetaQuest and Horizon OS. My name is Mike Lamprinos, and we're going to walk you through some of the tools that we have available for you. We have two themes for you today. First part that I'm going to go in after this agenda of this slide is about how do you get to your first prototype fast. You have an idea, how do you go about developing it to a state that you can demo it to other people, maybe other folks in your studio, on your teams, or someone external, very fast. Because we believe a lot of these newer technologies, like mixed reality that are coming up, you need to really put some effort into prototyping to see how you get to your idea, to a working prototype very fast. But I know that's not the only part, but like before we move further, we're going to talk about some of the use cases that traditionally have been pretty difficult to get together, like multiplayer. If anyone has tried building a multiplayer title or a social experience before, you know that it can get extremely difficult to debug it, to set it up. You have to set up so many different things. So we're going to talk about some use cases that, with the power of building blocks, are now very, very easy to go and build. Then my colleague Ben will come on stage and talk about the section that I believe most of you spend most of your time, right? Iterating, debugging. You've built your first prototype. How do you go about making it into something that you can eventually ship to the store? So we have some really powerful tools available for you that we've been adding features based on your feedback. Two of them is Meta XR Simulator and Immersive Debugger, and Ben is going to go deeper on how to make the most out of these tools. Sounds good? Some notes? Good. So first, let's talk about setting up. So I mean, it's been a few years now. When I built my first prototype with mixed reality, I remember almost going crazy. I couldn't get it to work. I'm sure you've been there, right? What was wrong was, I hear some people agreeing. What was wrong there was that I needed to check a property box in Unity that it took me hours. Just go through documentation to figure out exactly what was wrong, just to update that box. That was not a very productive day, but that was one of the reasons why we built this tool called Project Setup Tool. Project Setup Tool is a tool that can help automatically find any configuration issues on your project and very quickly fix them. You just click Fix All, and everything is done for you. Can I see if anyone has used Project Setup Tool already? OK, we got a few folks here. So let me go through what Project Setup Tool is for the folks in the room that haven't used it today. And then we're going to talk about all the new things that we're bringing to Project Setup Tool later this year. How you find Project Setup Tool? So once you've installed the latest Meta XR all-in-one SDK, or if you are an Unreal developer, the Meta XR plugin, you can open the Tools menu from the toolbar and just select Project Setup Tool. You will see a list of outstanding issues here that require fixing, and you will see different categories of recommendations as well. You can either click Fix All, and all the configurations will be fixed for you automatically, or you can select which fixes you want to apply. It's really that easy. You can make your project MetaQuest ready in a few minutes, and the alerts are proactive. So as you go about developing your project, changing some of the features, you will see more recommendations popping up. Now, this year, we'll be bringing new improvements to Project Setup Tool, including helping you set up and configure your headset when you want to use MetaQuest Link. So we know that can have a lot of different configurations. We want to make that easier. And as with everything else with Project Setup Tool, this will be done automatically based on which features your project is using. So just to wrap up this section, two very important things I want you to take from this. First of all, if there are Unreal devs in the crowd, Unreal project setup tool is available for you. Make sure you're on the latest Meta XR plugin. The same features that are available in Unity are available there. And one important, I guess, reminder, right? We're adding new setup rules almost in every release. We now have dozens. I don't know if we're in the hundreds yet, but there are a lot of setup rules that we're adding on every version. So make sure that you update your project regularly to the latest SDK to make sure that you receive all the latest updates. Sounds good? All right. Now that you're set up, what comes next? I want to talk to you about the tool called Building Blocks, which can help you quickly start building with different Meta Quest features. With Building Blocks, you can easily discover and add different features to your project, and they contain different features from all of the Meta XR SDKs. You can see some of the features here. Let's see how it works. You go to the same menu as you found about Project Setup Tools, so all our tools are available under this menu. You see a Unity 6 preview here, so later this year, once Unity 6 is out, that menu will be on the top bar. Right now it's on the bottom right corner. You select Building Blocks, and let's say you want to build a mixed reality game that uses pass-through, room model, and probably hand tracking to make like a natural experience. All you have to do is come to this window, either drag and drop those blocks or just click the block, and they're automatically into your scene. They're already pre-configured, and any dependencies of any other features are automatically edited into your project. That's it. You're now ready to go about building your experience. Now, what happens after you install a block is, as I mentioned, all the dependencies are already taken care of for you, as well as configuration. And developers have loved building with Building Blocks so far. This is one of my favorite quotes from Arnold. I'm sorry, but it's just not fun making games anymore, thanks to these Building Blocks. It's just too easy. Arnold is one of our star developers, and he used Building Blocks to get some first prototypes going that eventually made it to the store. You can check his titles. And it really speaks about how Building Blocks can be both a starting point and something that you build towards a more full project, right? So they're great for finding the fun. So if you're doing game jams or quick prototyping, they're really, really good too. But they can also be a robust starting point towards your final project. Building Blocks are prefabs, so as with every other prefab in Unity, you can go and see and edit whatever you would like. And later this year and next year, we're working on improvements to make it even easier to take Building Blocks closer towards your production builds. Now, you probably know some of these Building Blocks. We've mentioned them already if you want to start building for mixed reality. So pass-through, spatial anchors, we have interactions and gestures. We have over 30 Building Blocks available for you today, and we're adding new ones in the latest releases. So another reason to remember to update your projects. Now, we talked about how we want Building Blocks not just to be a starting point when you're experimenting with different features, but how they can enable you to build towards use cases. And there are some use cases that we see that fit two criteria. First, there are experiences that we see developers finding product market fit, consumers loving, like social and multiplayer experiences. Some of the top games on the store are social experiences, and they tend to be very engaging, but they also tend to be very difficult to build. So we set out to build those multiplayer Building Blocks, focusing on some of the most complicated use cases, that tend to take development time and require a combination of different APIs and, in some case, different infrastructure layers. So we have released a set of multiplayer Building Blocks that they're using. They come with out-of-the-box support for either Photon or Unity's NGO, and they combine multiple of our APIs all together. So it's not just a thin layer. We've done all the hard work of combining the feature with the infrastructure layer. So you can just drag and drop as you're used with different Building Blocks and get started towards your first multiplayer prototype. Pretty cool, right? Two key use cases that we see emerging in the ecosystem is co-location and co-presence. So co-location is about two different people being in the same physical space using a Quest headset that are interacting with each other and virtual objects. An example of that is a virtual chess game. And also co-presence, where you're enabling people in different locations, sharing a virtual space. We'll continue to release more social multiplayer building blocks, as we believe this is an area that, first, we can significantly simplify your development workflows, especially around prototyping, and two, some of the use cases that we see very promising results from developers. Another use case, a new category of content that we're seeing emerging is tabletop experiences. An example of that is Demio, if you've tried that on the store. And we've seen a lot of promising content coming live. So this is one of our showcases that's available to download on the store today, and we're open sourcing soon. And we will be releasing a set of building blocks that help you build some tabletop experiences that are centered around the surfaces that exist in most people's homes. So be on the lookout for the new tabletop experiences coming later this year to help build towards your first mixed reality experience. I'm particularly excited about these ones as they tend to be very fun and engaging experiences. Excellent. To recap, we started talking about Project Setup Tool, which can help set up your project very quickly, automatically, so you don't have to go through documentation pages. You just fix everything with one click. And we talked about building blocks. Over 30 available today to start either prototyping or going towards your proper full-scale build. We have multiplayer building blocks out today. So if you are interested in exploring social use cases, give them a try. And we have more, especially tabletop building blocks, coming together later this year. So don't forget to update our latest SDKs in the Unity Asset Store to make sure that you're able to use those building blocks. And we talked about how do you get to your first prototype fast, right? You have an idea, you go about building it, you use building blocks, drag and drop, you build some logic, but that's not all, right? I'm glad we have so many people here that have been developing for a while with us. I know that most of your time is actually spent on testing, iterating, putting the headset on, putting the headset off, cycles of that. And we know that once you have your prototype, it can take 6, 12 months or more to get it to a state to release it to the store. So we've been focusing a lot on how we provide you some very powerful tools to help with those testing and debugging workflows. And we're going to watch a quick introduction to MetaXR Simulator, and then my colleague Ben will be up to explain deeper some of the features that we've been building for you and introduce you to a new tool called Immersive Debugger. Thank you.
At Meta, we are continually working to improve developer workflows and make it easier for developers of all skill levels to create incredible mixed reality experiences. In this video tutorial, we'll walk you through using the Meta XR Simulator, a lightweight XR runtime that enables you to simulate VR and mixed reality features in pre-built or custom synthetic environments, all at the API level, and all without needing to wear a physical headset. With Meta XR Simulator, you have an efficient tool to iterate and test your single-player or multiplayer experiences from the comfort of your desktop with a mouse and keyboard, game controller, and Meta Quest controllers, along with effective ways to scale automation by simplifying your testing setup and debugging so you can spend more time iterating and building out your vision.
Thank you, Mike. Hi, everyone. I'm Ben, and I'm here today to challenge your assumptions about what it takes to do XR development. By the end of this talk, I want you to be excited about all the new tools that we have available for you to make your work more enjoyable and faster to do. These will include how to iterate your XR application faster without having to wear the headset, a new toolkit to do mixed reality development in a more robust manner, and finally, a new framework to do real-time debugging while being immersed. The first tool today is the simulator. It was developed to complement testing on link and on device. It is easy to install and will run your application very quickly. It supports many game engines, including Unity, Unreal, Godot, and others. It simulates physical reality because it allows so you can test against many different rooms layouts. You can simulate using an input system, which will allow you to test more intuitively. It has a built-in record and replay system, so you can automate more complex test cases. It is meant to be a reliable framework for doing both mixed reality and multiplayer testing. That's why it was used to develop so many of the samples and SDKs here at Meta. Since its release last year, we've seen many developers adopting it as part of the core workflow. For example, Jacob Rendon from Engine Room VR now uses it to test all of the core flows in their game. And we are continuing to improve the simulator on every release, continuing to add features, fix issues, and improve the debugging and testing workflows. Now I'm excited to review some of these new features and recent improvements. Here's a quick setup tutorial. First, install the all-in-one or standalone package. Then use one of the several methods in this. Then use a method to activate the simulator. And this will temporarily replace Link as the active OpenXR runtime. Then press the play button, and the simulator window will appear. That was really easy, right? Now, once we have the application running, we can talk about how we have improved mixed reality development with the simulator. We realized that mixed reality development is a real pain point for many developers. As Lucas Risotto from Pillow VR explained, users will play your application anywhere from gigantic warehouses to tiny bathrooms, and that MR is a use case nightmare. So we've heard those calls for help, and we have rushed to fill the development gap. We designed a synthetic environment protocol which will synthesize data for the pass-through, scene, and synthetic objects OpenXR APIs. To get started, select one of the synthetic environments from the OpenXR menu, and then press play, and you will see the pass-through is now composited behind your application's content. Also, scene anchors are embedded in each of the synthetic environments. These will allow you to test your game's mixed reality logic on the simulator just as it would on the device. We've also developed a system to export the scene anchors from the device into a JSON format for usage with a simulator. Finally, as we promised last year, if none of these options work for you, then you can always build your own synthetic environments. Just go to the synthetic environment builder documentation on the website to get started. Next, I'm going to show you how to use the input system with a simulator. OpenXR applications are immersive by their very nature. The headset and controller give you 18 degrees of freedom with additional input options with all the buttons and thumbsticks. So it's a challenge to simulate all of this on the desktop. That's why we've built an input system that supports all of the MetaQuest interaction profiles and will allow you to control all of these options. You can use the keyboard and mouse to simulate the inputs similar to a first-person shooter. Also, hand tracking is implemented in the simulator. Simply change the input path types from controller to hands in the input window, and you'll see that now hand interactions are emitted by the input system instead of the controllers. Now, if a keyboard and mouse are not fluid enough for you, then you can also use an Xbox controller instead. But there's even another, maybe better option. You can use the physical controllers to actually drive the input system. Once you get this enabled, well, you enable this through the physical controllers section in the settings window. Once you do get this enabled, you can see the virtual controllers move when you wave the physical controllers around. This should offer a more intuitive control option and even includes the ability to move the headset around using the thumbsticks. Now that we've learned how to interact with the game in the simulator, next let's move on to some of the other test infrastructure. The MetaXR provides many useful testing tools. The record and replay system allows you to create arbitrarily complex action sequences. It is straightforward to record actions and then replay them whenever that sequence is needed. It uses an algorithm to avoid ambiguities in the replay data so that you can get a precise replay even if you drop frames. It also supports a snapshot functionality to allow you to do post-replay comparison and validation to ensure that your game logic stays correct. You can also run multiple instances of the simulator on the same PC to test multiplayer testing scenarios. All the instances will connect to the same synthetic environment to share the same scene data. If a synthetic object moves in the environment, then all the instances will receive updates. Also, we support sharing spatial anchors between instances. There's also a batch mode that is useful for automated testing. This is how we test the XR simulator against the OpenXR conformance testing suites. Next, let's talk about how some of the tools were developed using the simulator. Here's some of the use cases of the simulator. It was used to develop the building blocks framework that Mike previously talked about and some of their samples. Both MRUK and the Immersive Debugger were partially developed in the simulator and work in it as well. Most of the samples that you can get from GitHub also run in the simulator, and this is very useful for a quick run-through before testing on link or device. You can also run the simulator without requiring a project reconfiguration, and this will save you valuable time when you do need to do on-device testing. Finally, let's talk about how the simulator now runs on the Mac OS. We recognize that the Mac OS is an important operating system for many developers and their workflows. So we didn't want you to have to compromise what operating system you need to use because of a technical limitation. So we ensured that the simulator has the same features on the Mac platform as it does on the Windows one. And it even comes in the same package in the next version. In that version, on a Mac ARM computer, you'll be able to download and install the simulator package, press play, and your application will appear in the simulator window in the same way as the Windows version. And like the Windows version, it supports Unity, Godot, and other game engines. That wraps up this presentation of the MetaXR simulator. And next, let's move on to the Mixed Reality Utility Kit. This toolkit is designed to allow for building mixed reality content and making your game logic easier to develop. Sorry, I have a lot of content to go through, so I'm going through it really quick. But let's try and finish it. So we know that developing for the mixture of the physical and digital realities is very challenging. Where should the application place content in unknown spaces? How should the application work and feel in any of the multitude of different user rooms? That's why the MRUK was developed. It's a collection of algorithms to simplify mixed reality development with the MetaQuest devices. Sample algorithms include raycasting to anchors, checking for reachability, building nav meshes, and locating spawn points. For example, if you're building a tabletop game, it allows you to answer questions like, how can the app ensure that the game content was spawned on the table? Where is the closest point on the table to my controllers? How can the application ensure that an AI agent walks around the table instead of through it? How can it make lighting effects from the game content look realistic against the physical table? These algorithms allow you to do mixed reality development faster because they're able to analyze arbitrary room layouts and provide robust and reliable solutions. Once your Once your mixed reality application is running and works properly, you can debug it in an immersive manner. This leads us to the Immersive Debugger, which was developed to streamline link and on-device iteration. Here's a matrix of developer options and some of their advantages. If you use the Unity editor mode, it is the easiest to get started with, but also provides the least functionality. The Meta XR simulator allows you to both debug and do mixed reality testing, but does not allow you to use immersion. The link system allows you to be immersed in your application, but you can't do any interactive debugging. So the Immersive Debugger was developed to allow for real-time introspection of properties and visualize data via gizmos. The Interactive Debugger is an inspector interface at its core. You can mark C# properties with annotations and make them inspectable. You can also attach gizmos to properties with compatible types. Then you can run your application on link or on device and activate the control panel. In the control panel, you can go to the inspector to view values, tweak them, and see the effects on gameplay. You can toggle gizmos on and off for real-time 3D visualization. You can also open the console interface to see all the Unity logs to rapidly diagnose issues without having to take off your headset. Now let's review what we've learned today. We've covered how to test applications rapidly with the XR simulator, develop smarter mixed reality experiences with MRUK, and finally, how to accelerate your debugging process with the Immersive Debugger.